All right, in this section, I'm going to talk about how to solve equations using direct and indirect variation. So direct variation is going to use a very simple equation, which is y equal kx. In this situation, k is like the slope, it's the rate of change, and x and y are the things that vary directly with each other. So they might say something like the cost varies directly with the number of items purchased. And so X is going to be the number of items purchased, and the cost is, how much it costs. All right, so it'll tell you something like when 15 things are purchased, the cost was $38. And then it'll say, what is the cost? It'll ask you a question. What is the cost when 70 are purchased? Now, there is a shortcut you can do with these direct proportion when there's only two things involved, but I'm going to go ahead and work it the long way. Then I'm going to show you the shortcut because the shortcut doesn't work as well for the other problems. All right, so you have your basic equation. So you plug in the given information. So when 15 things are purchased, the cost was $38. So you just divide and find your K. Grab my calculator because it will be a decimal. So 38 divided by 15 gives you 2.53. So K is equal to 2.53. So then you put the given information and what you just found into your new equation. What is the cost? So K is 2.53 when 70 are purchased. So just take 2.53 times 70, and your answer is 177.1. So your cost would be $177.10. Okay, now the shortcut on a direct proportion like that is to just set it up as a proportion problem, like one fraction equals another fraction. So that would be when 15 things are purchased, the cost is $38. What is the cost when 70 are purchased? So the number purchased is on top, the cost is on the bottom. You could also do 38 over 15 and x over 70. You could do 15 over 70. And then as long as your second fraction kind of matches the way you set up your first fraction. Once you have this set up, you cross multiply. So you multiply those two numbers together. So 38 times 70, and then you divide by the other number. So 38 times 70 is 2,660. Divide that by 15, and you get the same answer. You get that x is 177.10. And actually, this one is 177.33. Because over here we rounded, this was 2.53 repeating, and I rounded it to 2.53, so this is actually a little less. This is a little more accurate because we didn't round at one point during the problem, but it would round down to $177. So that's how you set up a direct proportion. Now it could vary directly with more than one thing, okay? So the volume of something could vary directly with the length and the width. Oops, so you can see it. So if I say the volume varies directly, and sometimes it'll say varies jointly. The volume varies jointly or directly with the length and the width. So then it's got to give you some information. It'll say when the length is 8 and the width is 4, the volume is, let's say 88. So you plug all this stuff in. So 88 equals K times 8 times 4. So 88 divided by 8 times 4, which is 32, is going to give you your K value. So 88 divided by 32 is 2.75, which means your equation, oops, sorry, I'm moving this down, there we go. So 8 times 4 is 32. 88 divided by 32 gives you your K value, 2.75. So that means your equation is 2.75 L times W. So then it's going to give you some information. It'll say, what is the volume when the length is 10 and the width is 7? So volume is 2.75 times 10 times 7. So as far as story problems go or word problems go, these direct proportions are about the easiest types of problems to do, because it tells you the information in a sentence, and you just write the equation from that. It's not tricky to write these equations. So 2.75 times 10 times 7 gives you a volume of 192.5. Okay, so let's talk a little bit about indirect.